Hi everyone, I hope that you're doing great. I'm on fire as usual. In this video, we're gonna see how to build graphical apps on Windows using Swift. Yes, we're gonna use a swift-win32 library or a GitHub repository to work on this. So let's get right into it. Let's go. Okay, first of all, before going any further, let's make sure that we have the latest release of Swift on Windows, because as you may have seen, Swift on Windows currently is still getting more updates, is still really fresh and new, so make sure to get the latest release. So either this one, the Swift 5.3.2, or the development snapshots from the main branch. I'm gonna download this in this video. I'm gonna use this for the next steps. After you download and set up, make sure, so here's the link. After you download and set up Swift for Windows, follow this link, the second one, to get started. So you have to scroll a little bit to reach Windows and follow all these steps until here. So you have to do also this step because it will be useful later. And that's it. Just one thing here, use the x64 native tools, not the x86 as it's written here. x64. And do all these steps and we'll check that everything works correctly and we can continue. So see you. Okay, here we're back. Now we are on Visual Studio Code to quickly check that the setup is correct, the setup of Swift for Windows. What do we have here? We have a hello Swift file, hello.swift, so file, and we want to compile this script to check the setup. Okay, the command is swift-c, swift compile command. So it's the command that you all know and love, swift compile. The name of the file, like this. If we want to give an output name other than the default name, it's okay. And then we do the double ampersand to execute just after to run the binary just after the compilation succeeds. One more thing to add. So this is what we should do in Linux or Mac OS. This is okay, but on Windows we need, currently, maybe it will change in the future, but currently we need to specify manually the SDK path, like this, dash SDK. The SDK path is in an environment variable which is set up when we install Swift on Windows. So we just write SDK root, and that's it. So we're on PowerShell, we write it like this. On classical command prompt, you write like this. Just a little small difference. Since we're on PowerShell, we reference the environment variable like this. On SDK root. Let's run this. As you can see, the compilation succeeds. We have our binary, and we have the print statements on the console. So our Swift setup on Windows is correct, is working. Next step, run graphical applications. Let's do it. Now let's take another look at Swift on Windows page to see what we can do to build graphical apps with Swift on Windows. So here is the link here that you can also open on your browser if you want. But let's take a look at the page here, since we're here. So if we scroll a little bit, we'll see that there is a demo calculator application. And there is a link here. Let's see. So this is an app written in Swift. So let's see where it takes us. So it takes us to a repository called swift-win32. Oh, great. So there is a contributor to Swift, which is the official Swift for Windows maintainer, as I'm speaking. I think his name is Compnerd, his alias. So let's see what this is about. It's binding. So yeah, this is what we want. As you can see here, this is what we want. This is what will allow us to build graphical apps with Swift on Windows. So just go back to the main branch, okay, which is more up to date. So here we see more interesting stuff. So let's follow the tutorial here and see where it gets us. Here we go. First thing first, let's get the URL of the repository. So let's clone this here. Okay, I made a copy. Let's go back to Visual Studio Code, and let me go back to the parent folder, go to my sandbox folder where I do my experiments, and clone the repository. Let's paste this. Okay. Next, it says to, when we see build requirements, so we all have these requirements if you followed the previous guides. And now to build, the recommended way to build is using CMake. So in order to use CMake, we need to use the x64 native developer tools. Command prompt. Okay, this is how it looks like. This is what you get when you install Visual Studio with CMake and all the other tools. It allows you to access these tools from this terminal without having to worry about the setting path or configuring variables and so on. So we have CMake here available, so great. So let me just go to the folder where I have cloned the repository and continue our exploration and see if we can build this some graphical applications. Let's go. Now we are on the swift-win32 cloned folder. So we're on the correct location, and I have here the GitHub repository with some instructions, and we're gonna follow them to see what happens. Okay, let's run the first command, CMake, with a lot of parameters. So this command prepares the environment with the necessary configuration and files for the Ninja build system to build. So here we're not using SwiftPM. SwiftPM is compatible, but it's not recommended right now for this project. And CMake plus Ninja is equivalent of SwiftPM for Windows. So we have two solutions on Windows, but SwiftPM, of course, will be, I think, the recommended way in the future, but we'll see how it goes. Okay, now that CMake has finished preparing for the compilation step, let's see with some tasks done by CMake. I'll let you take time to look at what is done, but I just would like to highlight that here we have the CMake command downloaded some dependencies, particularly SwiftCom, which comes from another GitHub repository. And this is really important for the later step. I'm not gonna spoil right now, but you see Swift communication okay, or com Windows com. Maybe it can give you some hints. Okay, let's run the second command. Here we go. Okay, it may take some time. It takes some time. I'm hearing my hard drive doing some things. Okay, I had to press enter to wake up my terminal. This is a common problem that I have with the old school Windows command prompt, is that sometimes I have to press enter on my keyboard to wake it up. Okay, now we have some results. They're not good, but we're gonna move forward, no problem. Okay, the problem here is that we have some file called in the SwiftCom package that I mentioned earlier that uses a member called iProperty back2 from WinSDK. It means that this dependency calls a property a member, sorry, named iPropertyBack2 from WinSDK. And WinSDK, what is it? It's the it's the files or the definitions from the Windows SDK. So when we installed Visual Studio, we have also installed Windows SDK with a minimum version, as you remember. And if you remember also, we have defined the module map, copied the module map from the Swift library, from the Swift folder, somewhere in the Swift folder, to the SDK. Let's check it out. Here we have the getting started page of the Swift toolchain. And if you remember, let me zoom a little bit, we have copied some module maps. So the module maps are files that allow the built Swift system to access other headers and other files. Here in particular, we have the WinSDK module map, which we put inside the Windows SDK in our Visual Studio setup, which will allow our Swift toolchain to access definitions from the Windows SDK. But the problem here is that something is missing in this module map because we don't have access to iPropertyBack2. So let me say it again. So we are looking for a member named iPropertyBack2 from the Windows SDK, but we don't find it. So there are two sources for this problem. Either the Windows SDK does not define at all this member, but this should not be a problem because we have downloaded the correct version of the Windows SDK as mentioned by the documentation. Or either the module map is not up to date, does not make the link between this member, sorry, and the Swift toolchain. And we're gonna explore this hint, and we'll see how we can solve this. So let's search for iPropertyBack2 and see where we can find it in the Windows SDK. So let me try a blind search, iPropertyBack2 WinSDK, and one of the first results is that we have the name of the file in the Windows SDK that contains this interface. Let's do a quick search, iPropertyBack2, and you see it's here. So let's check out in our local Windows SDK if we have this file defined. So we have found where the class is defined. Where the interface is defined. Let's check it out in our local Windows SDK. In order to get the location of the module map, we have a simple solution, is to take this, just this, and echo it in our terminal. And here we have, two backslashes. When we copy and paste, remove the extra one in the File Explorer. So I'm gonna copy and paste in File Explorer, and I get this, folder. Let me zoom a little bit. Okay, and let's look for two files, OCIDL.h. Here it is, and the module map. Here it is. So the two files are here. Let's see what's inside each of them and see how we can fix our problem. Here I have both OCIDL.h and the module map files opened from our Windows SDK, as you can see here on the path on the top of the screen. Let's first check here if we have iPropertyBack2. So I have the search window on the other screen. And yes, we have the property, sorry, not the property, but the interface or the definition, iPropertyBack2, which is here. So we have our file here, which is not accessible from the Swift build system. So let's check out the module map and see if this file OCIDL.h exists. OCIDL, and as you can see here, OCIDL doesn't exist. as you can see, the modules are a lot of modules are already defined. It's just saying that some headers are available in the Swift build system, CMake, Ninja, and so on, SwiftPM. And you see that a lot of header files from the Windows SDK, a lot of library files, lib files also are exported. And as you can see, since the Windows Swift for Windows is still work in progress, some definitions, some exports are missing. So let's add the one that we want. And as you will see, sorry, it's really easy. Just copy paste an existing one, give it a name. So let's call it OCIDL, just to reference the same name of the file. Put the name of the file here. So this header, we want to export it, and there is no lib associated. It's just a definition file. So that's one worry, less worry for us. And that's it for me. I think that we have done the necessary things to fix our build problem, because now when Ninja builds the project, it knows that the iProperty_back2 exists, because the module map somewhere can say where iProperty_back2 exists, and it's thanks to this export that we have the definition. So let's try this again. Now is the moment of truth. Let's try to build again the UI catalog sample project. So I'm back on the x64 native tools command prompt in my the swift-win32 folder, and then I typed the command for building the project again, and then here we go. As earlier, it may take some time, so you can enjoy a coffee or a little walk. Yes, we have reached the first step, so it is very good news. The first step of the compilation succeeded. Let's wait a little bit more. Don't forget to press enter from time to time, just in case. Okay. Second step completed, and third step completed also. Our program has been built. So it is a graphical application written in Swift and that runs on Windows. Yes, congratulations. Thanks. Let's run our UI catalog application. It's located in the build bin UI catalog.exit. Let's run this, and here we go. We have our beautiful graphical app written in Swift using swift-win32 library. Button works. We can scroll. We have an image. We have a slider, and so on, and so forth. So great stuff. Great stuff. And now, since we are here, let's take a look at the other examples. Here we have two other examples, calculator and hello world. So let's try building those. Let's start with the hello world. So let's call the command back, which is this one, the ninja, just the ninja command. CMake, no need to run it again, just run it once for the whole examples. Now let's make the hello world first. Sorry, here we go. Let's build it. So the binary has been built. Let's run it like this. And here we have the window of hello world. There is no hello world text, but it works. And finally, let's add the run the calculator example, and run it like this. And Unfortunately, it doesn't run. I don't know why yet, but this example doesn't work on my current setup. But anyway, we have two Win32 examples at work, two graphical apps, and the Hello World is a good starting point, I think, for your own applications, your own experimentation. So it's good enough, I think. And before finishing, let's summarize what we did and give you one last hint about module map, and then we can talk about other things or finish this video. To summarize what we did in this video, we have set up with Swift on Windows using the official documentation, and after that we cloned the swift-win32 repository. We ran the commands in the building section. However, this command failed, and we found that it's because of the module map, which did not export the OCIDL file, and we did it by hand. But there is another way to do it, to get an up-to-date module map without modifying it by hand. And the other solution, I didn't test it, but it should work, is to go to the Swift GitHub repository, because it contains up-to-date files, and then go to File, here, WinSDK, and search for WinSDK module map. And you should have a more up-to-date file. As you can see, it was updated 7 days ago, and you can even search for OCIDL, and you see that it's effectively here, ready, and already exported. So what you can do, download this file and replace the existing one with this one if you want. So here you go. I hope you enjoyed. I hope you learned new things. I didn't dive yet into code, Swift code to build the graphical apps. Here in this part, I just focused on building the existing examples, and we'll see next what we can do. Bye bye. Happy coding. See you.